You have two eyes. This gives you a chance to experience depth perception as you triangulate the position of objects. Lets you know how far away they are. But there's a lot of 3D vision that can be experienced with just one eye. For example, close one eye and look at your finger right in front of your face. Then at something that's far away. And then look at your finger again. And then at that thing that's far away. And you'll notice that your finger passes in and out of focus. Here's another trick. Close one eye and hold your finger in front of your face again. Then move your head from side to side. You'll notice that the objects that are closer seem to move more than the objects that are far away. That's called parallax. You often witness parallax when driving around. The distant objects seem to move a lot less than the close ones. This is also how the distance to stars are measured. As the Earth goes around the sun, the further away stars move less. Also, sometimes an object seems closer simply because it's larger. This is called foreshortening. All of the effects you've seen have been done with a single eye, the lens of our camera. But what about two eyes? For 3D to be convincing, each eye must see a slightly different image, both in angle and in parallax. This was achieved more than 100 years ago with photographs taken with two very close cameras. It's called a stereogram. Here's one of a man-eating tiger. Doesn't it feel like the tiger is really there? Now, I can't really show you 3D in this video, but I can explain how it's achieved. The real trick is in getting each eye to see something different on the same screen. These two images are then blended in the brain as a single solid 3D object. Try this out. Hold up both thumbs in front of your face and look past them. This will make a third 3D floating thumb appear between them. It looks real and solid, doesn't it? That is a stereograph. Your eyes are like two cameras assembling a 3D image. But how do you convince each eye that it's seeing something different than the other? The old way was to look through two separate tubes at a pair of slightly different images. Another way is to filter out which type of light is getting to each eye. Sometimes this is accomplished by projecting red light for the right eye and green and blue light for the left eye. Later, these images are assembled in the brain. Another method is to project two images of individually polarized light. One is polarized horizontally for one eye, and the other image is polarized vertically for the other eye. Another problem is that you can't turn your head very much when you're watching the movie. Well, that is, unless you have circularly polarizing glasses, which do allow for some head rotation. You might wonder why it is so easy to fool the brain into assembling images. But that's what the brain does all the time. It assembles two different images into one blended reality. Here's an experiment you can try. Go to a dim room and bring a flashlight with you. Then cover one eye and shine the light in the other eye. The pupil contracts, even though it has not seen any extra light. The eyes are not individuals, but are permanently linked in the back of the mind. There are exciting new developments in 3D viewing without glasses. The way it's being done is there are bars in the TV that are letting each eye see a different thing, so you don't need the glasses anymore. This technology is new and it's not quite ready yet, but who knows what the future will hold.